Hi, what I'm going to do is do a bit of a power analysis on a Raspberry Pi Zero wireless. I've got Wi-Fi enabled, I have Bluetooth enabled, serial enabled, connected to a HDMI output, running normal Raspbian image, and I'm going to be powering it from a little power analyzer designed for IoT applications, just like this, made by Koitek over in Europe. It's their OT-I ARC, and it's a 0 to 5 volt, 0 to 5 amp power supply and power analyzer that gives you microamp resolution, allows you to have serial inputs and outputs, so you can log what's going on from a device, in this case from the serial console output of the Pi. You've also got GPIOs, inputs and outputs. You've got normal analog input, and you've got another analog, that's a 0 to 5 volt, and another one which is designed as a sense across, for example, external current shunt. If you want to measure a secondary supply, like the 3.3 volt rail or something, if you could break that out. So we're going to run that all the way from the Pi startup through to the Pi shutdown, and we'll turn off the Wi-Fi in between to see what happens with that. For video capture of the Pi, I'm going to use a Camlink HDMI capture device, and I'm using OBS, the open source studio, for the first time ever. So this probably looks like rubbish, but too bad, because it's the technical stuff that's interesting. So for the setup in the OT software, if we have a look at that, you can see a graph display. I've got project settings up here. I'm going to run it at 5 volts. I'm setting my current limiting to 750 milliamps, and the digital IOs on it I'm going to run at 3.3 volts. I'm going to log the main current. I can optionally log all these other values, including the main supply voltage, but I have that turned off down here, so that we only have the main current and the log messages from the Pi. In here I've turned on the internal UART, and I'm going to log it 115k. So apply that, go OK. And if we have a look at both the Pi and the OT software together, jump over, turn on the recording, set the auto scale, and fire the Pi up. You can see the initial current usage. It's up to about 200 or so milliamps during the boot up process. And very shortly we should see boot up messages, which you can there. So that's the HDMI output on the right hand side, and the left is the serial console stuff being captured by the OT ARC software. And I'll show you something neat you can do with that shortly. We'll let the device boot all the way up. And we should have the desktop up in just a moment. We've already got the log on message up on the serial console. Yep, so we've now got the screen up. You can see our current power usage over there. So if we switch back to just the OT software, you can see in here that our average usage at the moment is about 100 milliamps with these spikes and things. That's just while it's idling along, waiting at log on. We'll go back to scaling the result, make it fit. Over here, that was obviously quite a bit more. These funnies that you're seeing with the screen, the cursor being offset. That's not a problem in their software. That's a problem in the way OBS is capturing the screen. Anyway, so it's along here, we're talking about 100 milliamps idle roughly for the Pi. It's pretty cool. So if we go back and look at the Pi as well, and if I go and turn the Wi-Fi off, although it may already be off, let's have a look at that. I'm using a little Bluetooth keyboard and mouse, so Wi-Fi is turned off. So if I turn Wi-Fi on, let's see what that does to the power usage. There's a bit of a spike, I'm guessing, as there was some disk activity. You can see that at the end. So our power usage, we'll analyse this in a moment. We'll just remember where those things were. It went up by a bit, not a huge amount, when we turned Wi-Fi on. Now if we do a shutdown on the Pi, so I'll bring up a terminal. And we'll do a shutdown minus H space now. Space minus H. Can't actually read what I'm typing because the screen preview is too small. But there we are. Just doing the shutdown. If we just look straight at the logger screen, you can see the current has dropped right down. So we'll stop the log there. We'll turn off the power and we'll stop the log there. So this was our average without Wi-Fi turned on, so about 99 milliamps average. And then with Wi-Fi turned on, it's at 137, so it's gone up 38 milliamps. There are some peaks there, but yeah, it's hard to tell what's going on in between. But if we go back here to our logs, the whole idea of this logging stuff is that you can see what the power usage is at different times on your IoT device. So here, this was just after our startup. You can see we were taking 142 milliamps, and that's just as the kernel's booting up. Then we can click on other entries as we go down. You can see this cursor slowly moving along as all the different devices turn on. If we'll be able to find, let's see if we can see this, where we are here. I'm guessing that's going to be down the list quite a bit. Yeah, so that happened after we had the console messages start up, because I've got logins enabled, so we missed the other bit. But you can see the general idea of being able to click somewhere in the log and being able to straight away see what the power consumption was at that stage. So I go over here, so let's say we want to go, great, so what happened here and how much power do we really use? If we click over here, we can then zoom in on that. The sample rate, I think, is about 4K samples per second, so it's pretty reasonable. But you can go, okay, well, at that point there, we were taking, whatever it was, 140 milliamps, or sorry, 400 milliamps or something on those spikes. And these ones, the average current there, or maximum current there, was up to 330 milliamps. So obviously you've got to allow 400 or 500 milliamps, even for a Pi Zero W. And then during the shutdown, it gets interesting as well. So that's the shutdown sequence. That's when the LED flashes to indicate that you can power off the Pi. But then here in the actual shutdown state, you're still taking 41 milliamps or something. So you're not really turning the thing off. So if you did have it running on a battery supply, and you were going to use the GPIO startup shutdown options, you're still going to be drawing 40 milliamps while it's doing absolutely nothing. So it doesn't really turn off, so to speak. So anyway, I hope that was kind of interesting, because it was useful for the project I'm doing, so I thought somebody else might find it useful. If you like it, good. If you don't, fair enough. It's up to you. Cheers.